Hi guys, the video gave us quite an insight into what is the most talked about revolutionary topic of 21st century, big data, didn't it? Welcome to the group presentation of big data and problem in its analysis. I and Kinkin shall try to inform you guys through this presentation about the various aspects of big data and what problems are we facing currently in its analysis. The video you just saw enlightened us how much of data is generated at every second of the clock through text messages, YouTube videos, Facebook posts, Twitter tweets, blog podcasts, email, music, and many other such sources, and how data is the most precious raw material in the 21st century. Harnessing the unstructured data and analyzing it to develop business insights is the topmost challenge currently for all the major companies around the world. Currently, even the topmost companies admit they are barely using just 2% of the right information to support their business decisions, and most of them use just the structured data to make their business decisions. They lack the information of what is happening in the supply chain with partners, social media channels. This humongous volume of data may seem like a big problem, which can be converted into a big opportunity using the right skill sets. As seen in the video, companies can outperform their peers and competitors by up to 30% by investing in big data analysis and generating effective business strategies from them. So, is big data an opportunity or a big problem? Let's find it out. So, let's look at a general explanation of big data. Today, the world is becoming an increasingly digital space, as you all might have experienced. We manage, share, and store our lives online. Data is gathered from our devices, computer, and smartphones that collect and transmit information on whatever we do. But that is just the beginning. Soon, most things, including our TV, watches, cars, etc., will collect and transmit data. Data explosion started in the year 1970. In fact, if we gather all the data from beginning of time till year 2000, it will be less than what we now create in a minute. Isn't this surprising? This phenomena is transforming our understanding of our world and our place in it. It's become known as big data. Big data could be invaluable in business. It could provide a window into the lives of our customers and that we have never previously imagined. But there is a problem. How do we unravel the strands of big data and pick out the relevant parts? Data comes from so many sources. How do we know where to look and how do we access it? In short, how do we turn all this information into knowledge? Businesses are currently using big data to better understand and predict customer behavior and optimize and improve their business processes. The possible applications of big data are endless. We're just seeing the emergence of big data economy. All businesses in the world need to consider the potential of what big data analysis can provide or risk being left behind. Volume of data is growing from terabytes to petabytes. To understand the problem in this analysis, let's look into what are its characteristics. Big data, like cloud, is not an implementation of technology, nor does it have an explicit set of solutions. Big data defines class of information management problems that are difficult or impossible to effectively solve using conventional tools and techniques. These problems are often characterized by the 5 V's, that is volume, velocity, variety, veracity, and value. The volumes of data that companies collect overwhelms the people, process, and technical capability of business enterprise information management group. You will likely need different set of tools and techniques to solve this kind of problems. Velocity problems occur when the data arrives so fast that you just cannot write all of that into any database. You may also have need to make decisions based on incoming data and currently have no automation to support those huge amount of data. Then there is variety. Companies collect end user documents and real-time sensor content from millions of machines, surveillance information from retail stores, voice recording from thousands of customer calls and their questions for new products, and various sources of social media. Not only you have a significant variety of data, but you also expected to correlate all the data to understand the sentiments of specific class of customers. Veracity or the perceived lack of information is another problem. For example, some departments of a company may doubt the veracity of truthfulness of a person captured in the video surveillance data. Storing the video file is quite easy. Properly assigning the facial recognition metadata is much more difficult. Finally, there is a problem of value. The value of your intellectual property and its vast volume is presumed, but is not exactly known. More time is consumed by companies into what questions they should be trying to ask to gain business insights than assigning resources to answer them. Now that we have seen the characteristics of big data, we will further see what problems occur in big data analysis. The importance of big data doesn't revolve around how much data you have, but what you have to do with it. You can take data from any sources and analyze it to find answers that enable cost reductions, time reductions, new product development and optimized offerings, and smart decision making. When you combine big data with high powered analytics, you can accomplish business related tasks such as determining the root cause of failures, issues, defects in near real time, generating coupon at the point of sale based on the customer's buying habits, recalculating entire risk portfolios in minutes, as well as detecting fraudulent behaviors before it affects your organization. Well, big data is certainly everywhere. Everyone seems to be collecting it, analyzing it, making money from it, and celebrating its powers. Whether we are talking about analyzing zillions of Google search queries to predict flu outbreaks, or zillions of phone records to detect signals of terrorist activity, or zillions of airline stats to find the best time to buy plane tickets, big data is on the case. By combining the power of modern computing with the plentiful data of digital era, it promises to virtually solve any problem: crime, public health, evolution of grammar, perils of dating, be it anything, by just crunching the numbers. But precisely because of its newfound popularity and growing use, we need to be level headed about what big data can and can't do. The first thing to note is that although big data is very good at detecting correlations, especially subtle correlations that an analysis of smaller datasets might miss, it never tells us which correlations are actually meaningful. A big data analysis might reveal, for instance, that from 2006 to 2011, the United States murder rate was well correlated within the market share of Internet Explorer. Both went down sharply, but it's hard to imagine that there is any causal relationship between the two. Second, big data can work well as an adjunct to scientific inquiry, but rarely succeeds as a whole replacement. Molecular biologists, for example, would very much like to be able to infer the three-dimensional structure of proteins from the underlying DNA sequence. And data scientists working on the problem using big data as one of the tools among many. But no scientist thinks you can solve this problem by crunching data alone. No matter how powerful the statistic analysis is, we will always need to start with an analysis that relies on our understanding of physics and biochemistry. Third, many tools that are based on big data can easily be gamed. For example, big data programs for grading student essays often rely on measures like sentence length and word sophistication, which are found to correlate well with the scores given by human graders. But once students figure out how such a program works, they start writing long sentences and using obscure words rather than learning how to actually formulate and write clear, coherent text. Even Google's celebrated search engine, rightly seen as a big data success story, is not immune to Google bombing and spam dexing techniques for artificially elevating website search replacement. Fourth, even when the results of big data analysis aren't intentionally gamed, they often turn out to be less robust than they initially seem. Well, the fifth concern might be called the echo chamber effect, which also stems from the fact that much of the big data comes from the web. Whenever the sources of information for a big data analysis is itself a product of big data, opportunities for vicious cycles abound. Consider the translation programs like Google Translate, which draw on many pairs of parallel text from different languages. For example, the same Wikipedia entry in two different languages to discern the patterns of translation between those languages. In those cases, any initial errors in Google Translate infect Wikipedia, which is fed back into Google Translate, reinforcing the error. A sixth worry is the risk of too many correlations. If you look 100 times for correlations between two variables, you risk finding purely by chance about 5 bogus correlations that appear statistically significant, even though there is no actual meaningful connection between the variables. Absent careful supervision, the magnitudes of big data can greatly amplify such errors. The big data as its best when analyzing things that are extremely common, but often falls short when analyzing things that are less common. For instance, programs that use big data to deal with text, such as search engine and translation programs, often rely heavily on something called trigrams. Sequences of three words in a row are called trigrams. Reliable statistical information can be compiled about common trigrams precisely because they appear frequently. But no existing body of data will ever be large enough to include all the trigrams that people might use because of the continuing inventiveness of language. One last problem I would like to state is the hype of big data. Champions of big data promote it as a revolutionary advance, but even the examples that people give of successes of big data, like Google Flu Trends, though useful, are small potatoes in the larger scheme of things. They are far less important than the great innovations of 19th and 20th centuries like antibiotics, automobiles, or the airplane. Big data is here to stay, as it should be, but let's be realistic. It's an important resource for anyone analyzing data. Here we will look into how we can solve the problems discussed of getting insights from big data analysis. Data integration, or to be technical, data harmonization is absolutely essential for getting the full advantage out of your big data. Data integration addresses the backend need for getting data silos to work together so that you can obtain deeper insights into big data. In the book Big Data and Beyond the Hope, the author Sikopoulos found that we see too many people treating this topic as an afterthought, and that leads to security exposure, wasted resources, untrusted data, and more. We actually think that you should scope your big data architecture with integration and governance in mind from the very start. Not only this will save the janitorial work that is inevitable when working with data silos and big data, it will also help to establish the fourth V, that is veracity. In other words, the trustworthiness of your data, which will underpin the authority of any insight you gain from analyzing your data. The first step to integrating your data is to ensure you have got clean data. Big data consultant Ted said that 80% of the work data scientists do is cleaning up the data before they can even look at it. They are data custodians rather than data analysts. Anything you have done more than 3 times, you should automate. It might take longer the first time, but the other times you will save time and focus on analysis. Now let's see how to clean and maintain this data. Removing duplicates. If you're using multiple channels to capture data, such as through your website, customer care center, marketing leads, and you are running the risk of collecting duplicate information, there are tools to help you remove duplicate data. For instance, if you work with Google Contacts, you can merge your contacts. Verifying new data. To verify new data, we need to set company-wide standards on verifying all new captured data before it enters the central database. Put in checks to see if customers isn't ready in the system, or that they are not in the system under a different name or under their email addresses. Update data. Keep your data updated. You can do this by using parsing tools, which scans all the incoming emails and updates contact information as it comes to hand. Implementing consistent data entry. To have consistent data entry, we need to ensure that all the employees are aware of company-wide data entry standards. For instance, each customer record has to have first and last names. Well, we got an insight into what is big data, and we have seen some of the problem in its analysis. Thank you for your time.